Hello, so this is a video for 10-2, multiplying matrices. We are going to go a bit further than multiplying by a scalar. We are going to take a matrix and multiply it times another matrix. Now, this is going to be a little bit more challenging because it's not as straightforward. You don't actually match up like the top left with the top left and just multiply it. You have to follow a specific algorithm. And it's really hard to just kind of look at an example without doing it. So we're going to learn a lot more kind of on the back part of our notes instead of me just kind of talking and showing you. All right, so let's get into it. The first thing that you need to learn is how to find the dimensions of the product when you multiply your matrices. So I think the easiest thing for us to do is to just kind of look over here. And we are going to multiply a 2-row by 3-column matrix times a 3-row by 1-column matrix. So something neat happens when you want to multiply your two matrices. If you write the dimensions right after each other, do you notice how you've got the same number of rows and columns? So this would be columns in your first matrix compared with the rows of the second matrix. As long as those are the same, then your product is going to wind up being a 2 by 1, okay? If these two numbers are not the same, then you are not going to be able to multiply your matrices. So let's look at something a little bit more generic. So basically you have any matrix with dimensions m by n. Now remember, n is the number of columns in the first matrix. That needs to be equal to the number of rows in the second matrix. As long as those are equal, then your final product dimensions are going to be m by p. All right, so let's do an example. Like I said before, it's easier for you to do an example and you'll see it kind of in work instead of me just like talking at you. All right, so if you look at this first matrix right here, I am going to write down the dimensions. It's got 2 rows and 3 columns. B, right next to it, I'm going to change colors. I'm going to say that this one has 3 rows and it has 4 columns. So what I do, I had a teacher teach me this a really long time ago. I actually box in the middle 2 numbers. If those middle 2 numbers are the same, then what I can do is I can mark it out and write down the 2 remaining dimensions. So if I multiply these 2 matrices together, I get a 2 by 4. Second example. Now this one has dimensions of a 2 by 3. This one has dimensions also a 2 by 3. Now, while I can add these 2 together, I can also subtract them. I am not going to be allowed to multiply them together because look, I don't have a matching set of dimensions. So you've got to make sure that your columns of your first has to match the rows of the second. So this is actually another impossible problem to do with matrices. So just kind of reiterate one more time, just make sure that the product of the 2 matrices, it has to be your columns have to equal to the number of rows in the second one, okay? And the result would be what is left over. Now this part's going to be a little bit intimidating at first, but I think once you get a hold of the pattern, the process of it, it's really not that bad, okay? So if you look at this top kind of example here, do you notice how you have the row? You have A and B. This row right here is going to wind up being multiplied times this column. So if you notice, you've got rows, columns, rows, columns. So that is the algorithm that you're going to have to follow when you want to multiply these 2 matrices together. But it's not, like I said before, it's not as obvious as you think it's going to be. So you write down the 2 that are in this row. So you have A and you have B, but each one of those numbers in the row is going to be matched with each number in a column. So you have A times E, and then you have B times G. So not only are you multiplying these together, you're also going to have to add them together. So we got lots of different things going on. And then this is just kind of an example of how to do it. That's not going to make a lot of sense right now. So let's go ahead and just flip it over on the back and let's go ahead and work an example. Okay, so let's start out with the easy stuff. We are going to figure out the dimensions of our product. So I'm going to write down the dimensions of each one of these matrices. So this is a 1 row, 2 column, and this one is a 2 row, 1 column. Since these numbers in the middle are the same, I can multiply them together, and whatever the result is will give me a 1 by 1. Okay, so I'm going to go ahead and put equals, and I'm going to leave a little bit of space, and I'm going to just put room enough for one number because I have 1 row and I have 1 column. So this part right here I think is really important in your organization for your algorithm to find what numbers go in your final answer. Okay, so I'm going to highlight this part right here. And then I'm just going to scoot over a little bit and I'm going to show my work here. Okay, so that yellow space right there for that one number, what I'm going to do is match the row and the column according to location. So I'm going to use that first row and I'm going to multiply that times that first column right there. Okay, so here's what you do. This is your first row. That's row 1. So I'm going to write down these two numbers, but I'm not going to put them next to each other. I'm going to say 5, but then I'm going to leave a space for its matching column. So I've got 5 plus -2. So now I'm going to pair it up. So this is the first row. I'm going to pair it up with the first column. So now I'm going to go in here and I'm going to put 4 and 9. So now that you have it set up, you can either do this part in your head or just use your calculator. This is going to give us 20 plus -18, which gives us 2. That is the number that you put in your answer when you multiply. And that's it. That's what you're going to do. And that's pretty much the pattern for any matrix multiplication problem. So let's try something a little bit more difficult now. All right, once again, we're going to start out with the easy part. We are going to write down the dimensions of each matrix, and we're going to see what our final result will be. Since the rows and the column match up, I'm able to multiply them together. Final result is going to be a 2 by 2. So I'm going to put a little bit of space in between here. I know I've got 2 rows, and I know I have 2 columns. Okay, and you don't have to highlight. I just like to do that because I am a visual learner. So what I'm going to do is I'm going to multiply this using that same pattern, but I've got 4 final answers that I'm going to include in my matrix because it's going to be a 2 by 2. So the first thing I'm going to do is I'm going to figure out what goes here in this yellow section. And if you notice, the yellow section uses row 1 and column 1. So what you're going to do is you're going to go back over here to your problem and you're going to look at row 1 and column 1. So you're going to match it up. 6 times 0 plus 4 times -3. Okay, 6 times 0, 4 times -3. So one more time, where am I getting that 6 and the 4? That is part of the first row. And then the 0 and the 3 is from that first column. So once again, you can either use your brains or use your calculators. You're going to wind up with -12. And I'm going to put that number right over here. Now, it does not matter which one you choose to do next. I'm going to go ahead and I'm going to do the blue one. So that means that I'm going to take the first row and I'm going to multiply that times the second column. Since I'm using that same row, I know I'm still going to be using 6 and 4, but I'm going to have new numbers because it is a second column, which is 2 and 1. So I'm going to replace that with a 2. and a 1. And that is going to go in that blue space. So I have 12 plus 4 gives me 16. All right, let's do one more. I've got the green section here. This is going to be row 2 and column 1. So I'm going to come back over here. I'm going to circle row 2 and column 1. So I'm going to be using 0 and -5. And for the column, I'm going to use 0 and -3. So altogether, that's going to give me a positive 15. Now, if you're feeling confident at this point, go ahead and write down what you think is going to go in that last part. Go ahead and pause that video right now, and then unpause it when you're ready to see. Okay, so for the last one, I'm going to be using row 2 and column 2. Okay, so I'm going to still be using 0 and -5, but this time I'm going to replace it with 2 and 1. So 0 plus -5 is -5, and that is my final number. So hopefully by now you're catching on to the pattern in which we have to follow to multiply. Yes, it's a lot more complicated than adding and subtracting, but it's really not that bad once you kind of get used to it. So question number 3, the dimensions are going to be a 3 by 2, and this one is a 2 by 3. So it looks like we're going to wind up with a big 3 by 3 matrix here. So let's leave some room. So 3 rows and 3 columns. Now that means, whoops, I'm going to have all of these different numbers I'm going to have to find. So you're going to have to go over here, and you're going to have to do 9 different operations. So the first operation, you're going to have to do row 1 times column 1. So this is going to be a big problem. Now, are these really difficult? No. But do you have to be organized? Absolutely, you have to. So let's go ahead and just knock the first 3 out, and then I'm going to let you do the last 6, and let's see how you do. Okay, so since this first one right here needs row 1 and column 1, I'm going to use these numbers. Oops, I meant row 1 and column 1. Okay, so 3 and -4 pair up with -1 and -6. So that's -3 plus 24 is going to give me 21. Okay, moving on. I'm going to do row 1 and column 2. So if you repeat the same row, you can use the same 2 numbers, but then you've got a new column. So now I'll be using 7 and 2. So 21 plus -8, that's going to give me 13. Oop, I just wrote it in the wrong spot. Okay, and then the last bit over here, I'm going to use the same row and column 3. So 3, -4. But this time I'm going to use -2 and 4, which is going to give me a final total of -22. All right, so at this time, let's go ahead and give you a shot on the final 6 here, and try to work it out on your own. And when you're ready, go ahead and hit play, and let's see if you get the same numbers. Okay, so hopefully I did all of this right. Y'all let me know if I got a mistake in here, but I showed my work, and just take a second and see if you got all 6 of those correct, and if not, just let me know. The only thing I have left in this lesson is to talk about the different identity properties, because I know it's going to be on your test, and I know it's going to be on your benchmark or the ACT. So identity just basically means, like, if you add something, it's not going to change its value. So if you have a 2 by 2 and you want to add the 0 matrix, it literally is just all zeros. So if you get asked about an additive identity, it's just a matrix that consists of all zeros. Multiplicative, on the other hand, it's not going to be all zeros, because y'all know if you multiply by 0, it's going to like cancel everything out. But what will work if you have a 2 by 2, you notice that your ones are diagonal. Same thing with a 3 by 3. So just in case it asks you about an additive or a multiplicative identity, the identity is going to have a 1 in each diagonal, depending on the size of the matrix. And that's pretty much it. Your homework is not out of your textbook because it doesn't have a lot of really good examples. So Delta Math, on the other hand, does. And it's even got some guided problems in case you're having any trouble trying to figure it out. So go ahead and head on over there and just let me know if you have any questions. Thanks.